Okay, welcome to the 3D programming course. This is a presentation on the exercises done so far. So the first side, complete start using WebGL only, and we can easily see it right here now. So if I go into the code and see the code, you can see this folder and also the positions are set here. We can also pay attention to this JavaScript file here. It's similar to the way you load JavaScript file in HTML, traditional HTML. And then you can see this app.prepare. It is saying an argument of the method of the main. Actually, in the JS file, this is the canvas parameter passed into this function. And this app is actually the instance of the class that we have created in our JS file. I will go back to that in a few minutes. And also take note of this type, this shader type, this type X shader.com. And you see how we can use the DOM parsing to get this to be sure it's either this buckets or this. So we can actually take these uniform values right here. Uniform variables are, from my understanding, these are variables that have scope across different files. So from what I can understand from observing the source code, then let's go to the JavaScript file. Everything looks right good so far. The JavaScript file is just a normal JavaScript file. In this case, it's like a Node.js class, and we have some declarations at first. Then we have some methods inside. So you setting a canvas, and then you're getting the first element to the canvas. And then we initialize. This serves as our main. We call all the methods in this class, in this particular method. It serves as our main. So we clear the screen, enable the depth test, we throw it on the screen, and we also write to the JavaScript console when we drawing is completed. This is actually not visible on the screen, this console.log. This is actually visible as a log file which is only needed for debugging processes when you debug your application. It doesn't show on the screen. So this with this WebGL has to be initialized. You get the context, then you get a bit. We have to handle this error gracefully. Should WebGL not be supported in any browser we have our season, so it's like we just catch this exception and throw either an error or we handle it some way cleverly. So then also it's possible we have to initialize the data, so we create the buffer on the vertices and then bind these vertices, then create the vertices itself with its coordinates. That's why it's 3 here, because there are three dimensions. Then we copy this into the buffer. Then we set the item size. This is the number of items available in the vertex. Then we specify the number of vertices. This number of vertices is very important because most things in 3D programming, when we are creating images, we use a collection of rectangles. So if you can, with clever manipulations, you can have a lot of items also that comprises of different triangles forming different shapes. Then we come again to this console.js because we want to have a base for debugging our application. That's why we have this console log somewhere. It's not actually helpful in the application, it's helpful to the debugging of the application. Then this shaders also, we have these buckets and private shaders. So we create some variable for it also here. We create the shader program and we also add shader to the shader programs. Make the shader, check if it was successful. It's always a good habit to check for errors because errors can happen anyway due to mistakes, so just maybe a kind of API method is deprecated, so it's always better to check for errors everywhere. So we enable the program access program. Then we do this rendering actually. The rendering begins by just filling the entire canvas area. Then clear the screen, then use a program, then bind then create vertices. Then at the end, we just start on the screen. Just very good. Then this, I alerted you to this type in the HTML file. This actually the part of the protect when protect shading actually. Yeah, it's like an if statement with DOM passing. Your passing is by DOM. So then it allows you to compile the shaders, put fragment and inverted shaders. Then you add it to the shader source. Then compile the shader source, check for errors also. Then you have to create this object that serves as the instance of this WebGL class, and this is what we actually exploited when we call this method of this upload prepare. So it's like we're just calling this prepare method only, because this prepare serves as the main for our class and everything looks fine. So I think this looks quite good, and when you run it, you get exactly the description of the exercise. It looks quite nice. Voila, now you can see it. It's a rectangle, a green rectangle in a canvas, and it looks fine. So this exercise done. So now let's do the second exercise. This has to deal with 3.js only. We don't use 3.js. It already has some default implementation of WebGL built in actually. So I actually prevented doing the underlying low-level stuffs because I believe it's already done in the 3.js. That's the need for a framework. When you do things in framework, you use the framework. You don't have to. You don't need to reproduce the framework or rewrite the framework if there's no need for it. So now this works this way actually. It's just we have some files like these 3.js files and the library. I use the detector.js to actually check for WebGL support in browsers. So if it's not supported in the browser, since most browsers actually are HTML5 supported, it will have a canvas. So I can really create a canvas and use the default canvas. I will describe it in this class JS file. So everything was quite good now. So we'll move over to the JS file and see what we can get over there. So this looks quite different from the previous class. So the increase of the maps and the same then I have to review the methods compared to before because there's something that is relevant because now we are not doing the low level stuff because we have a framework for doing that, so we don't need to put that ourselves with that. So this works quite nicely now. The aspect ratio, the near far, the clipping plane and stuff like that. Then the screw the scene between the camera, then we try to make one position the camera fixed so that it's like we're using a 3D dimensional plane as a 2D because for displaying rectangles you don't actually need 3D actually, you need 2D. So it's just like showing the camera position, one axis suspended and that's changing. So this is what we check for the WebGL support. So if it supports WebGL, we just click the WebGL whenever. And if it doesn't support, we create from the canvas. That's HTML5 support at least because HTML5 supports canvas. Canvas is default there. So we will create and create spaces. So sometimes you need to be careful the order in which these are created. So you check which order is before the other one, clockwise. Yeah, basically, clockwise. So you guys are in the clockwise manner. Based on how you load it into make sure you do it otherwise you may have a black screen that will show the color of the material you added to it, just like black triangle, which may not be what you actually want. Then you have to create this material because this material is actually how you decide the color of this object that you are trying to create. So you put in the color inside and also Then you create a mesh and add your scene, your mesh to the scene that you've created previously. Then you see you just render. So this is quite simpler than before because we're using a framework. So we don't have to do the ground level work. So we don't really have to care much about the projection planes and projection matrix. And actually WebGL helps us if you want to do some projection matrix stuff and model view matrix manipulations when you're trying to get an impression of perspective in a video, or you're trying to represent your translation and rotation in front of matrices. So it's easier to manipulate. So you can use the matrix support provided by 3.gs. For this exercise, it does not require those kind of specific features. So I use just the features needed for this exercise and leave the rest for the coming classes. And everything looks fine. Then we enter to the screen and print an app as before. Well, we can see right here this prepare method here because yeah, the canvas is not needed. So here the canvas is not needed. So everything was fine now. The canvas is not really needed, so there's no need to pass the canvas here. So let's go. I'll fix it here now. Let me see if everything would go fine. Okay, we can see we still have a blue triangle here. So now everything looks fine. So thank you very much for your time. You will see the video posted online and everything. So you should have access to my learning diary, and you can make some comments that you may like, and everything looks fine. Thanks so much for your time. So thanks, goodbye, and